Mutually exclusive events and independent events is what we are going to see in this lesson. But please don't forget to subscribe to the channel. Now, if you have mutually exclusive events, in simple terms it means that those two events cannot occur at the same time. For example, you can't sneeze while breathing. You can never. I think you know that in biology, that whenever you are sneezing, breathe stops for a moment. So those two cannot occur at the same time. They can never occur. Another example is a simple example, like you can't be in, say, which state can I use? You can't be in Kampala and at the same time be in Nairobi. It cannot happen. You either in Kampala or Nairobi, but you can't be in two places at the same time. So being in Kampala and being in Nairobi at the same time, we say those two are mutually exclusive. So that's the idea. It means that the intersection of those two are valid is unempected. So their probability of occurring is automatically zero. So the moment you say that two events are mutually exclusive, it means that the probability of them occurring together, the intersection, is always zero, as you can read through the statement. Now, remember when we have derived in the last lesson, we said probability of A union B is equal to probability of A plus probability of B, then minus the intersection. But because these two are independent events, we said that the intersection is zero. So we put here zero, this is what we made with. Simple as that. Let us come to independent events. Events that are to be independent if the occurrence of the other cannot affect the other. In simple terms, you can do them at the same time. What can that be? You see, you have a heartbeat at the same time you are walking. So the two events can occur together. Or some people, like now, I'm teaching while I'm recording a video. So those two can occur independently. So if they can occur together, they can exist, and so that those two are independent. So A and B as independent if and only if. This sign in mathematics means if and only if. Probability of A intersection B, we can get their product independently. Now remember from this game, where now this, I replace it with this from this here. So now let us see how we can handle these questions. Events A and B are such that probability of A is this, then probability of B is this. If A and B are mutually exclusive, find this. You know that? Now, if they are mutually exclusive, and the probability of the intersection is zero. So it means that now, probability of A will be probability of A plus probability of B. I would have said minus probability of A, but because you see that now probability of A intersection B is equaling zero. So that's why I'm not including it there. Now, these are the probability of A and the probability of B. But from the question, they are giving me that probability of A is equal to 0.2. Then probability of B complement is equal to 0.3. This is the complement. So now I can know if I have a complement, I can get the other. Why? How? We said, remember, we said that. But we said probability of B plus probability of B complement is always a 1. Probability of this occurring and not occurring is always 1. So this will be probability of B plus 0.3 equaling to 1. When we make probability of B the subject, we'll get 1. Take this side and 0.3. Our probability of B will be 0.7. Now you have this, you also have this, you can come back and substitute into our formula that A union B. Probability of A plus probability of B, because these are independent and mutually exclusive events. So you have now 0.2, then plus, this is going to be our 0.7, and then we add these two, you see that we are going to get 0.9, and that will be our probability of A union B. Now, when I come to this, they are telling me probability of M is 0.4 and probability of N is 0.5. If M and N are independent events, find probability of N intersection N. So always be careful, you check if if they give you a complement, then you start by getting the other one which is not a complement. Now these ones, they are not complements. So, he said if they're independent, now these ones, they're telling us that they are independent events. He said they are independent if probability of A, those two, M intersection N is equal to probability of M times probability of N. So this A and B are double variables. You can change, they can give you P and the Q, R and the S and so on. Now here they're giving us M and N, but the idea remains the same. So in our solution, since they are independent, you know that probability of M, because they are independent, means that this will be probability of M, now times probability of N. As simple as that. This is our part A. So now this will be probability of M from the question. Our probability of M is 0.4 and probability of N is 0.5. So I'm setting them here. 0.5 and when multiply, I'm sure I will get 0.2. Probability will be 0.2. So remember here, the word independent, that's how we handle them. And the counterpart B, they are asking you now, find probability of M union N. Now we say, hope remember how we can expand this. Probability of M plus probability of N minus probability of M intersection N. But we say now these are independent. So you can easily write this as probability of M intersection N. So now substitute, this is 0.4 plus 0.5, then minus, say all of this is here, and 0.2. Now, the question, now this one is very easy because they ask you to get this, but if they don't ask you to get this first, you always know that this is going to be the product of those two independent probabilities. So this would be 0.9 minus 0.2, it will be 0.7. That will be your answer. The denominator of C, you want to get probability of M complement, section N complement. So if they're independent, you can easily get this will be probability of M complement, then that is probability of N. Now, how do you get the probability of M complement? This will be the same as 1 minus probability of M, then times probability of N. Where am I getting this? From the fact that probability of M plus probability of M complement is always equal to 1. Now I want this, so I will take this the other side. Probability of M complement will be 1. Probability of N. As simple as that. So the moment you say you have a complement, the other will be 1 minus. The other which is not a complement. So like here I say, if you want this, now it will be 1 minus probability of the complement. So you can easily interchange that always. So 1 minus probability of N was 0.4. Then times this probability of N, which is 0.5. So here is subtract here, we get 0.6 times 0.5, which will be 0.3, and that will be our answer. Or you can use the continuous table. Using the continuous table, so all you can say the probability of the from the continuous table. Of course, here you know how it's going to be because I'm seeing a complement here. So this will be N. Probability of N will be probability of M intersection N, then plus probability of this M intersection N, continuous table. Here we are using the continuous table. Continuous table. Stable. Now you see we have this. So if I do this, so we have this as 0.5 equal to the intersection was 0.2, then plus what we want, 0.n line intersection n. Take this side, so you have 0.3, and you now know that as the same answer if you use the continuous table also. University members, we are going to see more of this.